Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 5, Lesson 11, Volume with Fractional Edge Lengths and Unit Cubes. Now that sounds like a big fancy thing, but here's the deal. We've been talking about area already. And so if I gave you a square, see if I can do a little bit better. That's a little bit better. Not much, but a little. I give you a square. That is a two-dimensional figure, meaning essentially it's flat, right? If you're finding the area, you're just finding all this space that's in that square. If I give you a cube, now we're talking about something that looks like a box, right? And so that is like three-dimensional. So we know that it has depth. And so when we talk about volume, we're going to, instead of painting this wall, we're going to fill this box, right? We're going to fill it up. Okay. Let's take a look at what we're doing here. When we have a right rectangular prism, meaning essentially it looks something like this, or like this. It has a right angle, 90-degree angles, and it's not a rectangle. It's not a square. They are three-dimensional. Then there's a formula to find the volume of how much we could fill this space. And that formula is this. Volume equals length times width times height. And when you have your answer, let's say your answer is x, when we try to fill this space here and find the area, we squared it, right? And so we could count all the different squares. Well, here you're filling like essentially a box, and so you're putting a bunch of cubes in there. So your answer is going to be cubed, which is to the third power. Whatever your answer is, cubed, not squared, but cubed. So if you think about this box here, just think about the lowest level of the box. It's 10 inches long by 4 inches deep. And if these cubes are 1 inch by 1 inch by 1 inch, so we've got a bunch of little cubes, little squares that we could put in there. If we filled across the bottom, it would be 10 across, 4 rows deep, right? So you would have 4 rows of 10, so you'd be able to fit 40 cubes just on the bottom row. And then you'd have to fill that 6 high. So if you had 40, 6 high, 6 times 40, you would end up with 240 cubes, or 240 inches cubed, right? So if you can imagine taking little building blocks, and you have 10 across, and it goes deep 4, so you have 4 rows of 10, and then it goes 6 high because they're 1 inch cubes and it's 6 inches high, you end up with 10 times 4 times 6, which is length times width times height, which is what we just talked about. So if we take 10 times 4 times 6, 10 times 4 is 40, times 6 is 240 inches cubed. So if we look at this second prism, let's see which one would hold more of these cubes. Here we have 8 times 5 times 12. 8 times 5 is 40, times 12 would be 480. So, which is twice as much as the first box. So this prism would hold more, and even though when you look at it, they don't look all that different, right? You've got to do the math. And so when we have 480 inches cubed, you could fill this with cubes 8 across, and then there'd be 5 rows of that, but then that would be 12. You'd have to stack them 12 high. So there'd be a lot more. Okay? All right, let's look at our next example here. This is actually the same. If we go back to this first example. It's not working. There we go. This first example, which we decided we could, if the inches were 1 inch, or the cubes were 1 inch by 1 inch by 1 inch, 1 inch long, 1 inch wide, 1 inch tall, we could fit 240. So I'm going to put a little pin in that over here, and we're going to think about that 240. Now, we want to fill that same size box, but this time we're going to fill it with dice, so basically little cubes, right? But they've been cut in half. So instead of 1 inch by 1 inch by 1 inch, Now it's 1/2 inch by 1/2 inch by 1/2 inch. Now, what you might think is that because each one of these is cut in half, that you could cut this one in half. But remember, if the cubes are smaller, you can fit more in. So if you can fit more in, and they are all half here, you might think, well, maybe you take this original number and you would double it. Maybe you think, okay, well, maybe it's 480 because it's going to be twice as much. That's logical math thinking. That's a good hypothesis, but it actually doesn't work out that way. And so what it is that for each little cube, obviously this is not to scale, but let's say these are the little cubes, right? For each little cube, if it's half as big, you can fit twice as many across, you can fit twice as many deep, and you can fit twice as many high. So what you end up with is 2 times 2 times 2, which is 8. So it's 8 times the size of the original. So again, if we go back and look at that 240 number and multiply that by 8, we get 0, 32, 1,920 cubes that are 1/2 by 1/2 by 1/2 that you could fit into this prism. That is not the only way to solve that problem, however. It's probably not even the easiest way to solve it. So let's look at another way to solve for that same exact problem. So again, if we're looking at length times width times height, if the length is 10 or 10 inches and you have 1 inch cubes, you can fit 10 in there. But if you cut those in half, you could actually fit 20, right? If we look at the depth, they're 4 inches. If there's 1 inch cubes, you could fit 4. But since they're half as big, you can fit twice as many, so you can fit 8. And then, of course, 6 inches high. If you have cubes that are 1 inch, you'd be able to fit 6 rows high. But if they're half that size, you could fit 12 rows high. So now we can take our new length times width times height, 20 times 8 times 12. 20 times 8 is 160 times 12. I'm going to write it over here just for space reasons. It's going to give us 1,920 inches cubed, so you can fit 1,920 cubes in there, in the new box, or in the new size of the cubes. They would fit that many into this prism. Okay, let's do another example. Here we have another right rectangular prism. That we have 1 1/2 inch by 1 inch by 3 3/4, so 3 3/4 inches. The question says a 1/4 inch cube is used to fill a prism. So it's not a 1 inch cube, it's a 1/4 of an inch cube. How many 1/4 inch cubes does it take to fill the prism? What is the volume of the prism? And how is the number of cubes related to the volume? So we have 3 different questions we're going to answer here. Okay, to find how many 1/4 inch cubes fills the prism, what helps is to figure out how many would go across, how many would be the width, and how many would be the height. Well, if you have 1 1/2 inch, we could draw a picture here. So here's our 1 inch. Here's our 1/2 inch. If we're going to look at 1/4, we're going to break this into fourths. So each of these is 1/4. And then our 1/2 inch would be the same as 2/4, right? So we can count 1, 2, 3, 4, 5, 6. So 6 would go across. 1 inch back, right? If you have 1 inch, and you break that into fourths, there's 1, 2, 3, 4. So you could have 4 cubes wide, and then 3 3/4 inches tall. Well, if there's 4 and 1 inch, then 4 times 3 would be 12, plus the 3/4, so 15. So you'd end up with 15 high. So if we then take 6 times 4 times 15, I know that 4 times 15 would be 60, times 6 would be 360 cubes would fit 1/4 inch cubes would fit inside the prism. So, what is then the volume of this prism? Well, as we said before, volume is length times width times height when we have a rectangular prism. So we have 1 1/2 times 1 times 3 3/4. I'm going to convert these. So 2 times 1 is 2, plus 1 is 3. We end up with 3/2. Times 1, I don't even need to include that, right? Because anything times 1 is itself. So 3/2 times 1 is still 3/2. And then bring down 3 3/4. 4 times 3 is 12, plus 3 is 15/4. Multiply across. 2 times 4 is 8. 3 times 15 is 45. We end up with 8 goes into 45 5 times, which is 40. So we end up with 5 5/8 inches cubed would be the volume of the prism. How is the number of cubes related to the volume? We'll actually go over that one in class. That's a little bit more of an explanation than I want to get into with the time remaining. So we'll talk about that one in class. Essentially, though, the volume is related because it's how many cubes would fit high, back, wide, right, all the way across. And so if you took the 1/4 times 1/4 times 1/4, right, because it's a 1/4 inch cube, multiply those four together, you'd end up with 1/64. And then if you try to figure out, that would equal 360/64. Divide that, you end up with 5 5/8. So that's how it's related in a nutshell. All right. Key is, what else could fit in here? Well, you couldn't do 1/2 inch because that would leave space left over for the 3/4 inch here. So you could do, obviously, what we did, which was 1/4. You could also do 1/8 because 1/8 could fit into 3/4 or 1/2 or 1 whole equally. So we'll go through some more examples together in class and let you guys work on some of those. And we'll talk soon. Thanks for watching.